Hi, so our main focus here is to learn how to balance in basic and acidic media. Yeah, brought by yours truly. Yours truly. So, what is a basic media and what is an acidic media? So basically, when you talk of your basic medium or your acidic medium, you're talking of an environment that has more of the hydrogen protons. And then when you talk of your basic media, you're talking of an environment that has more of the hydroxide ions. And so this is where the concept of pH also enters from. So you have this thing called the potential of hydrogen, which basically means something that is less than 7 on the scale. And then you also have what you call the potential of the hydroxide. Yeah, but mainly we focus on this guy on top here, this guy on top here. So this guy on top, the pH, he's the inverse of the concentration. So to find him, you are going to say your pH is equal to, is it the log of 1 over the concentration? Concentration, eh? Yeah. Concentration of H. Something like this, something like this. So you have something like this. So if an environment has got plenty of hydrogen ions, the pH is going to be on the lower side, less than 7. And that's why on the scale we have anything that is less than 7 is termed to be acidic. And then if you have it somewhere around 3.5 being the demarcation between a strong acid and a weak acid, where a strong acid would be like ukuso, kumasai, dokuso. Below 3.5, so that's like 2, and then something greater than this, like 5 or 6, that's going to be a weak acid. But all in all, anything less than 7 is an acid, and we are saying that the pH has an inverse relation with the concentration of the hydrogen ions. So if you have plenty of hydrogen ions, then you're going to have a low pH, and a low pH indicates acidity. Yeah, and the opposite is true. And the opposite is true. Where for the opposite, we're focusing more on the hydroxide ions. So now let's look at how you can balance in an acidic media and how you can balance in a basic media. How to balance. So basically how to balance, we're balancing in both medias. So we're going to balance in acidic media and we're also going to balance in a basic media. I was not the one that wrote that basic. I was not the one. So the first step in balancing an acidic medium is that you have to split your equation into its half reactions. So these reactions are definitely going to have two half reactions, one for reduction and one for oxidation. So identify the compound being reduced, identify the compound being oxidized, and then write the two separate equations. That's the first step. Second step is us being able to balance all the atoms in each of the half reactions except hydrogen and oxygen. So balance all the other elements except hydrogen and oxygen in each of the two half reactions. And then after that, you're supposed to be able to now balance the oxygen ions. How do you balance the oxygen atoms? By adding H2O, by adding water. So if the right side has, let's say, one oxygen atom, then you're going to add one H2O to the left side so that you balance up the O and the O. That's what this means. Yeah, the other thing is what? You also have to balance. I missed one step. So after you balance the oxygen ions by adding water, the next step that's supposed to be in between here is that you're now going to balance the, you're now going to balance the H plus ions. Oh, you're now going to balance the H the hydrogen ions by adding H plus ions. Alright, so if on the left side you have hydrogen atoms, and these hydrogen atoms can either be free on their own or they can be combined to something. So let's say that water that you previously added here when you were trying to balance the O2, that water that you added had hydrogen atoms. So those hydrogen atoms need to be balanced on both sides of the equation. So on the other side of the equation you had hydrogen, but the hydrogen you're going to add it as a proton, H plus. That's what I mean. And after you balance the hydrogen, you're now going to balance the charge by adding your electrons. And remember that electrons are negative. So keep that in mind. And then after that, now you just have to combine the two half reactions after balancing everything, and then just proofread and cancel out what seems to be common on both sides of the equation. So this is specifically when you are balancing in acidic media. These are the steps that you take. And as you are writing down, you can also be writing the statements to say, okay, I am now balancing this by adding this, I am now balancing this. It kind of makes your work way neater than just writing anyhow. And then from there we can now balance in basic media. So when you are told to balance in basic media, the first thing that you're supposed to do is balance the equation as if you're balancing in acidic media. Do all these steps that we've done here. Split into half reactions, balance all the elements except hydrogen and oxygen. Balance the oxygen, balance the hydrogen, balance the charge, and write it back into one big equation and cancel out, the spectator ions, the ions that are both comma reactants and comma products. So that is the first step that you do in balancing in basic media. First, balance in acidic media. Then after you do that, now you are now going to add your hydroxide ions to cancel out the hydrogen ions, and that's the last step. And after that, you can just cancel the common things that are the spectator ions that are on both sides of the equation, on the reactant side and on the product side. So these are the steps by virtue of us labeling them down and arranging them in order in which you are supposed to follow. So now let's follow these steps to answer this question here that says, let us balance the following redox reactions in basic conditions. So we have silver mixing with zinc, and that makes silver oxide. And silver, Ag, what's Ag? Oh, silver is Au? Okay, whatever this is. And then it's reacting with zinc. And then it makes itself oxide plus the zinc now. So here, what is the first step that we are supposed to do? Let's take our time to go back. Our first step is that we're supposed to split this guy into the half reactions. So how do we split him into a half reaction? We're supposed to have an oxidation reaction and a oxidation reaction and a reduction reaction. So that's the first thing. So here we're going to have the first reaction, which is going to be an oxidation reaction, because what we're clearly seeing is that from this equation on top here, we have this guy here who I'm still not sure whether he's silver or mercury. Mercury in Chan. Okay, between silver and mercury. This guy must be one of the two. It should be silver. It should be silver. I think. I'm not sure. But yes. So you have him gaining one oxygen molecule. So that is a clear indication that he is undergoing oxidation, because we're just adding oxygen. Because basically these redox reactions can be defined from 4 perspectives. Number 1, from the concept of oxygen. Number 2, from the concept of hydrogen. Number 3, from the concept of the oxidation number. And number 4, from the concept of the electrons. Okay, so here we're looking at it from the concept of the oxygen, and then we're saying if you have a gain in oxygen, that's oxidation, and that's what's happening here. So reactant was Ag, but the product is Ag2. Yeah, so that's oxidation. And then the other one is going to be us changing from the zinc that has a charge to a zinc that doesn't have a charge. So this is going to be a reduction reaction, because we are now looking at the oxidation number. The oxidation number has reduced. Previously it was 2+, but it's now reduced to 0. When you have zinc like this, it means the oxidation number is 0. So the oxidation number has reduced, therefore, this reaction is going to be a reduction reaction because the oxidation number has reduced. And that is what we're going to have here. And that is what we're going to have here. So you need to look at all the aspects of redox reactions, keeping in mind that you can define redox reactions from 4 perspectives: the oxygen, the hydrogen, the electrons, and also the oxidation number. So from our first equation, we looked at it from the oxygen. From our second equation, we looked at it from the oxidation number. So all those concepts need to be integrated. So sometimes you're going to use the gain of hydrogen, loss of hydrogen, to know whether it's a reduction reaction or an oxidation reaction. But overall, this is your first step. Separate them into their half reactions. After that, now you're supposed to balance all the elements other than oxygen and hydrogen. Balance all the elements except hydrogen and oxygen. So when you look at this kind of first reaction here, are all the elements balanced? No, they are not. This guy here, who I'm now starting to be convinced that he's silver, there's 1 atom here, but this side there are 2 atoms here. So what is the best thing for us to do? How do we balance that up? We're basically just going to write a 2 there. But with the zinc, I feel the zinc is already balanced. So there's 1 atom of zinc this side. There's 1 atom of zinc this side. There's also 1 atom of zinc this side. So this one is balanced. So we're going to have something like this, and we're going to have something like that. That is how you balance all the elements aside oxygen and hydrogen. All right. And then from there, we're now going to balance the oxygen. How do we balance the oxygen? By adding a water molecule, or H2O molecule. So from our first reaction here, we see that on the reaction side, there is no oxygen, but on the product side, there is 1 oxygen. So meaning that we need to add 1 oxygen on this other side. How do we add the oxygen? We add the oxygen by adding the water. Since we only need 1 oxygen, we only add 1 water because 1 water contributes 1 oxygen. If we needed 2 oxygens, we would have added 2 waters like that. But here we only need 1 oxygen, so we're only adding 1 water. So we're going to have it like that. And this is going to be the reaction. But on the zinc side, zinc does not have any oxygen to balance, so we're not going to balance anything. We're just going to write it like that. And these are our first 3 steps. So keep it here. Let's go to the next step. What is the next step? Step 4. Step 4 is balancing now the hydrogen protons. Balancing the hydrogen protons, we said we're going to balance the hydrogen protons by adding the hydrogen proton. So from here, how do you think we're going to balance the hydrogen atoms? So on the reactant side, we have 2 hydrogen atoms that we got from the water that we added. So meaning that we need to add 2 hydrogen protons on this other side. And how are we adding these 2 hydrogen protons? We're just going to say plus H and a plus on top there. This is basically how we do it. But on this side, there is no hydrogen to balance. So this one is just, again, going to be written the same way. Okay, so we're going to have something like this. Yeah, this is basically what we're going to have. Okay, so we've balanced the hydrogen. After we balance the hydrogen, the next step is now balance the charge. How do we balance the charge? We balance the charge by adding your electrons. So here you need to count the overall charge this side. You also need to count the overall charge this side. So how do we do that? We are going to say, what is the charge here? The charge here is neutral, 0. What is the charge here? The charge here is neutral, 0. So here you have an overall charge of 0. What is the charge this side? You're going to find that the charge this side here, yes, it is 0, but here it is a plus. And how many pluses do you have? You have 2 pluses. So the overall charge here is a 2 plus. And how do you balance the charge? So here is 0, here is 2 plus. You can only balance the charge by adding a negative, which is an electron. An electron is a negatively charged guy. So if you add the electron this side, it is going to be minus 2. But ukudi plus 2. Are these the same as this? No, it is not. So adding an electron this side would not make sense. Let's try adding an electron this side. Let's add the electrons this side, but here let's add 2 electrons. So we're going to add 2 electrons like that. When we add 2 electrons, so this is going to be a 2 plus negative 2 like this. So this is going to give us a 0, meaning that the 0 that was initially here is now equal to the 0 that we have. Henceforth, to balance the charge here, we need to add 2 electrons on the product side. We need to add 2 electrons on the product side. Okay, so we're going to have something that looks a bit like the balanced charge. We're going to have something that looks like that. Okay, so we've now added 2 electrons on this other side. That's what we have. And then after that, now we're going to add, we're going to try and balance the zinc equation this side. So now for the zinc equation, what is the overall charge on the reactant side? We have a 2 plus. What is the overall charge on the product side? We have a 0 because this guy here is neutral. And then how do we balance the charge? We can only balance the charge by adding negatively charged particles. If we add a negative to the reactant side, it's going to be negative 2 as the overall charge. Negative 2 is not the same as positive 2. Therefore, adding electrons to the product side will not make sense in this specific scenario. Okay, let's change it up. Let's try and add electrons on the reactant side. So here there is a 2 plus. So let's add a 2 minus from the electrons. Let's add 2 electrons that are going to give us a 2 minus. So we're going to find that here we're going to have an overall charge of 0, and here we're going to have an overall charge of 0. So this means that these two guys are equal. Henceforth, we're going to have it being like this: 2 electrons on the reactant side. Yeah. That way, then we have balanced our charge. Now, after balancing your charge, you must make sure that the number of electrons in both of the half equations are the same. So in this question, they miraculously happen to be the same, but if they weren't the same, let's say here there was a 3, and then here there was infinity 2, then you would have crossed the multiplication. So you'd have said, okay, let me put my 2 here, let me put my 3 here, and then you multiply these two with the individual molecules. So you're going to find that at the end, the electrons are going to have the same number, which is important for the next step, where you have to cancel out the electrons. But our goal is that our electrons must have the same number. That's on step 6. The electrons must be the same number in both of the reactions. Okay, so once you do that, now you can now add your reactions, and then you can cancel out what is, like common. So the electrons were both 2, 2 on both sides of the equation, so we can cancel them out, and they disappear, and then the rest is going to remain like this. Yeah. So once you're done here, then you've balanced it in acidic media. Once you've reached at this point, then you've balanced it in acidic media. But the question is not asking us acidic media, the question asked us basic media. But the first step of balancing in basic media was first balancing in acidic media, which we have done. But let's take a step further by balancing in basic media. Now we said basic media, a basic solution is that has a high number of OH. High number of OH. Currently, the equation that we have has a high number of H+, meaning that it's an acidic media, and that's why we're balancing in acidic media. Yeah, but here we want to balance in a basic media, so we must see a presence of high numbers of OH. And how do we see that? We see that by when you look at, so these are the reactants, and then these are the products together with this guy here. So when you look at these guys, you assess which side of the equation has got a high number of hydrogen protons. So on the reactant side, there are no hydrogen protons. On the reactant side, there are no hydrogen protons. But on the reactant side, we have 2 hydrogen protons there. So we want to cancel out the hydrogen protons by adding OH. So how many hydrogen protons are there? There are 2 hydrogen protons, so I'm going to put 2 OH. So if I add 2 OH here, I must also add 2 OH here. So once I do that, this 2H plus 2 OH are going to combine together to make water, H2O. This one doesn't have anything to combine to, so it's just going to be alone. So we're going to have something like that. We're going to have the 2OH here, and this guy here and this guy here, which are eventually going to make water like that, and we're going to have the 2OH remaining there. And stop pressure. So this is basically how you're going to balance. That is basically how you're going to balance. And then lastly, we have these questions here that you can try out. And then you can send your solution. We proofread, write it nicely, and also write the statements. I highly encourage that for your sake as well, so that you are also not confused as you are writing and as you are